Okay, so let's see what this problem says. What is the magnetic field at P due to the current I in the wire shown? So the current is flowing like this, and right. So we will use the Barth-Savart law for this to find the magnetic field, and the basic element is uh, so the field due to due to a small segment of a wire carrying a current I is given by this. Alright, so this segment ds will produce a, and from the cross product you can, and using the right hand rule you can see that if you stick your thumb out along this line, yeah, of your right hand, you'll see that this current produces a field coming out of the plane of the paper at this point, and similarly this piece of the wire will produce a field uh, going into the plane of the paper. So these two elements are producing magnetic fields in the opposite direction at this point. However, this element is closer, so this element will produce a stronger field there. So the net field at point P will come out of the page of the paper. All right. Now, also from this equation, from the cross product, you can see that you realize that these two elements do not produce any magnetic field there. Okay. So now it's just a matter of adding the fields due to all of these elements, which are in the same direction, and subtracting the field due to all these elements, which are producing a field into the plane of the paper. So all these guys are producing, all these little elements are producing fields out of the paper. All these little elements will produce fields into the paper. Okay, so uh, now the magnitude of the, we'll call it uh, we'll call this curve 1 and this curve 2. Okay, so the magnitude of the magnetic field uh, due to elements on 1 is mu naught 4 pi I ds r square, and r is a square. Okay, so the field due to curve 1 is just the sum of all these, and this is mu naught I 4 pi ds by a square, and a square is constant for all, and the distance from the point P is the same for all elements, so it's just pi a, the length of this wire, which is half the circumference, and which is pi a. Okay, so B1, the field produced by the semicircle 1 is equal to mu naught I by 4 pi times pi a divided by a squared. Okay, so the pi cancels and one of the a is cancelled, so it's B1 is mu naught I by 4a, and this is coming out of the paper sheet. Okay, so coming out of the paper. So, and you can similarly calculate the field due to curve 2, and this field is going to go into the paper. Okay, so field due a similar, okay, is 4B. Okay, and so the net field at the center, let's add a page first. So the net field at the center will be B1 minus B2, and that's equal to mu naught I 4A mu naught I 4B equal to mu naught I divided by 4A 1 over A minus 1 over B. And since A is smaller than B, this number is bigger than that, and so the field is positive. Anyway, it's the net field is, there's the magnitude, and it's coming out of the paper. So that's the field at point P. Okay, that ends this problem.